distribution table. Okay? So what we're going to be looking here is what happens when we don't know the standard deviation of our population. It's the realistic spin on significance testing. Now this might look familiar to you because this is the same table we used when we were creating confidence intervals back before we left school. So check it out. This is how we use it for t-tests. Hold on. So on the side of our table, we have the degrees of freedom. And degrees of freedom is like how many times we need to slice a loaf of bread in order to get the number of slices we want. So if our sample size was 20, our degrees of freedom is n minus 1, or 19 degrees of freedom right here at the very bottom where we can't see. For the intents and purposes of this demonstration, we're going to be using a sample size of 16. And so we're looking for degrees of freedom of 15. So how many standard deviations, if we want to test at a 5% significance level, how many standard deviations away from the mean will we be? Well, across the top of this table, we see the upper tail probability P. So if we're looking for a 5% significance, and we have 15 degrees of freedom, a sample size of 16, I'm simply going to triangulate 15 and 0.05. So we see that we are 1.753 standard deviations away from the mean. Now compare that against a truly normal distribution where we know the standard deviation. 5% for that would be 1.96 standard deviation. So we see that we get a little bit of wiggle room when we're working with t-tests. All right, so let's try another one. If you can, think about it. If I have 10 in my sample set and I want to test at a 5% significance level, where would that land me on this table? All right, I've paused long enough. You can pause too if you want to do this on your own and just look. But a sample size of 10 would give me 9 degrees of freedom, right here. Triangulating over from my 5% significance and trucking along. There I go, 1.833. All right, so that's how we find the test statistic right there, the critical value. Looking at what would make it so we would reject our null hypothesis, and this example of 9 degrees of freedom and a 5% alpha, or an alpha of 0.05, would mean any t value beyond 1.833 would cause us to reject our null hypothesis. So what happens when we run the test, get a p-value, and need to figure out what the probability of that is? Well, if we're using the table rather than our TI calculator, then this is how you're going to do that. Say I have a sample size of 12. That would be 11 degrees of freedom, right? And I come up with a t-score, a t-value of 1.95. So I'm going to truck along here at 11 degrees of freedom, and I'm looking for 1.95, but there isn't an exact 1.95. 1.95 lies between 1.796 and 2.201, between these two values. And so then I'm going to go up here and find out that my p-value, the one that I'm interested in, the one that I found, is between 5% and 2.5%. That's below our 5% threshold. We could reject the null hypothesis if that was our alpha. So when you're using the table, you're actually finding a range where we're going to be. What if it's two-sided? If it's two-sided, we double the range. So this is between 10% and 5%, so we might have to we would fail to reject the null hypothesis in that case if it was, my alternative was that we were not equal to our null. So that's how we use the table to go forth and solve these processes. My suggestion to you, use the table if you have a question specifically asking about a critical T, and use your calculator for running the full process, the full calculation when doing t-tests.